Okay, so in this video, we are talking about some software tools that are available to actually achieve data science goals. So let's start by talking some of the Python packages that are available. I've chosen Python just because of my biasness and not just the biasness. There are some stats that say that Python is really trending in data science, particularly the survey conducted by KD Nuggets. It shows that Python is basically the most popular data science languages these days. But you can also consider R, for example, Julia or Scala. There are other data science languages as well, but it completely depends which language basically you are most comfortable in. But this Python is really trending. So let's start by discussing some of the packages that are available in Python, particularly to help data science. First, let's discuss some visualization packages. Data understanding, it actually requires, in most of the cases, it actually requires a lot of visualizations to get insight into the data. And there are several packages for that. For example, Matplotlib, it's available to do a lot of plotting, to a lot of visualization, both two-dimensional plots and three-dimensional plots, several base map plots, geographical plots, and a lot of stuff that is available in Matplotlib. Several times in classification or regression data, we need to actually relate different kinds of attributes together and see the correlations among attributes. If, for example, we have thousands of attributes, or maybe even hundreds of attributes, actually writing a Matplotlib code to correlate every pair of attributes and see the correlations becomes really hard. Seaborn is a more high-level library actually written on top of Matplotlib that actually supports this kind of complicated plots in really easy way in terms of the number of lines of codes we really want to write out. So this Matplotlib is most basic and most fundamental. Seaborn written on top of that is good for most kind of complicated plots. But both this Matplotlib and Seaborn, they are for static plots. Once the plot is available, you can just visualize it and cannot interact with that. In contrast, this library Bouquet, and also there is another library called Plotly. These library, for example, Bouquet is interactive plotting library. So you plot, you get a plot, you get a figure, and then you can just interact with that figure to analyze more. So whether these Matplotlib and Seaborn are for static plots, Bouquet give a lot of support for interactive plotting. And these visualizations are really required for understanding of the data, because understanding of the data, this actually serves as a prerequisite in actually selecting a particular model for answering or prediction, for answering a query or actually prediction for whatever kind of concept you are dealing with. So, and it is sometimes known as that understanding of the data is half of the modeling. So, and understanding of the data, one tool of that is visualization. So these are the libraries that give you very good support for visualizations. Care must be taken. In a lot of industry, the number of attributes are huge. I mean, the total number of features are huge, and there is no library so far available, and actually even human visualization is not more than 3D. So we cannot visualize more than 3 dimensions or more than three features. So these libraries should be used in a particular way. The code must be written in a particular way that may give you visualization for the dimensions that are available, not more than that. And there are certain ways to actually focus on certain kind of features as contrast to all of the features, and maybe visualizing just 2 or 3 features at once, and maybe triples or couples of those in different kind of visualizations to get better look and feel of the data that is available. So next we discuss the database library or the data handling library, that is Pandas. Pandas is really powerful library, that very powerful package that builds upon NumPy. basically NumPy. In Python, NumPy is a numeric array package, not just numeric. It actually handles a lot of different data types as well, but as long as all the objects are of the same type, NumPy is way faster than traditional lists or other data structures. Pandas basically is built on top of NumPy, and it gives you a very good support for handling large files of data and actually processing, applying queries on this data, cleaning that data, visualization of that data. Actually, this Seaborn is much tied up with this Panda object. So if you, for example, get the data from a file that has numerous amount of fields, the Seaborn actually works on the Pandas object directly to actually give you visualization and stuff like so. So this Pandas is really powerful library to handle large files of data and to actually manipulate and understand that data. Next, we discuss the scikit-learn, or written as sklearn, scikit-learn library. That is basic classical machine learning library that is available in Python. Very powerful. It gives you a lot of support for validation, even visualization, the classification boundaries, and the clustering actually groups and all that stuff. It includes all kind of classical machine learning algorithms. And if your modeling actually fall under the classical algorithms of machine learning, then sklearn might be the package you will be after. You'll be looking after. It actually gives the support of data preparation and encoding and cleaning and dimensionality reduction and a lot of stuff. I mean, this is for the classical machine learning models. If your problem falls under any classical machine learning model, then sklearn is the package that you might be interested in. Next, if your problem actually has to deal with numerous amount of data, a large amount of data, and you need a lot of accuracy, and you have those kind of computational resources as well to go after that kind of accuracy, then you should focus on TensorFlow. That is basically a deep learning library by Google. That is a library for deep neural networks by Google, and it handles deep learning is basically sometimes called the modern machine learning. So it is modern machine learning. Modern machine learning. A lot of times the classical machine learning algorithms, they actually do not perform well if you supply a lot of training data and you need a more sensitive accuracy. In that case, you may switch to deep learning in those kind of cases. And deep neural networks, the support of deep neural networks, including convolutional neural networks, recurrent neural networks, generative adversarial neural networks, reinforcement learning, and all that stuff is available in TensorFlow, and that's a very high level package. It allows you to write just a few lines of code to build very complicated models. So that is there by Google. Another deep learning library is Torch, sometimes called PyTorch. That is also available, and it is a good competitor of TensorFlow. It is hard to actually select one of these two, whether you go for TensorFlow or whether you go for Torch. The Torch has its own benefits, and TensorFlow has its own comfort zones and stuff like so. In my experience, I have seen that most of the people from industry, they actually use TensorFlow, and several people from academia, they actually use Torch. And I myself actually use TensorFlow for deep learning, but really which one to select is really I mean, you can go for TensorFlow, you will find TensorFlow awesome. You can go in Torch and you can find Torch awesome. Next, we discuss Spark. Spark basically is a library to handle large volumes of data in distributed environments. It actually supplies you cluster management, the data management on different nodes. For example, you have a lot of nodes. The Spark basically is a library to handle data storage on different nodes, not only the data storage, the data computation on different nodes. It builds on Hadoop. So it builds on Hadoop. So Spark. There are other packages as well. not just these packages I've listed. These are just Python packages. Even in Python, there are other packages as well. And if you switch to the languages, in each language there will be other packages. So the purpose of this, basically, this slide is to tell you that a lot of software support is available for working in data science. If you have data available that every organization basically records and log the data, if you have your data available, if you have particular question or query or the pattern that you want to find out from your data, software is available. Software support is available, tools are available, very specialized kind of tools are available, and you may very quickly model, maybe you can model very quickly your problem in the available tools, and you get the very first insight of what is happening. So next we discuss basically cloud computing. Although the software stack is all available and all that kind of stuff is available in Python and all other kind of thing, cloud computing become necessary in some cases where your data becomes very in really large quantity, and you need a lot of computational power to actually run your models. One way basically is to build a local machine or get all the computational environment locally that handle all these load balancings and all distributions on different kind of GPUs and nodes if you want to, and all that stuff. Other way is to go for cloud computing services that actually give a lot of services, including data storage services, backups, and data computational services. They actually give you virtual machines if you like. All the softwares are updated and there, and all these things are available on cloud computing. So it is always recommended to actually, if rather than building the local computational systems, it is good to acquire cloud computing services. They're up to date. All the data is actually at one place. You can work from anywhere. The software support, the software updates, the versioning control, all these kind of stuffs are available. Security is there. I mean, a lot of services are available these days for cloud computing. So cloud computing basically is the on-demand availability of computer system resources, especially the data storage and computational power, without direct active management of the user. The term is generally used to describe data centers available to many users over the internet. Large clouds, predominantly today, often have functions distributed over multiple locations from the central servers. If the connection to the user is relatively close, it may be designated as an edge server. Clouds may be limited to a single organization or may be available to many organizations, sometimes called the public clouds, and the single organization clouds are sometimes called the enterprise clouds and stuff like so. So clouds offer you services, software services, platform services, and the whole infrastructure, or basically virtual machine services as well. So if you're dealing with a lot amount of data and you're going to build a model that may be computationally expensive, you should go for cloud computing services. That is recommended. It has a lot of other benefits. It is scalable. According to your demand, it is scalable. If you need more computation, you can just pay a fee for that and you can scale it up. Later, if you want to scale it down, you can scale it down. The software support is available. The operating systems are available. The virtual machines are available. Backups are available. Central filing. You can work from anywhere. You need not to work on a particular machine and on a particular location or something like so. So there are several cloud computing services that are available. I'm just listing just most popular ones, just a few of those. Amazon, for example, is providing cloud computing services, sometimes known as Amazon Web Services. Not just Amazon, I mean Google is also in, and Google is providing, for example, this Google Cloud Platform. Microsoft is also not away. Microsoft is also given this Microsoft Azure and several more. And several more. I mean, the cloud computing services are there. Depending upon different prices, depending upon different requirements of your business, of your query, of your data, you may end up selecting one of these if you really don't want to build a computational system and the backup overheads and all that stuff on your own. You should look into one of the the services, one of the cloud services that are available. So next we discuss basically the most common sequence or pipeline that is available in any data science project. So let's discuss that. So first of all, I need to show you, I need to tell you that the pipeline that I'm going to give you is basically a sequence of a lot of steps, and these steps can be expanded further to explain more, or maybe compressed to single units depending upon different requirements. In particular, for example, first of all, you have to have data. To start a data science project, to start a prediction, to find out the patterns from the data, you need data. And this is important because sometimes the data for a particular task is really not available. And you need to actually collect the data, and you have to put a lot of investment on just on that data. And there are whole companies, whole industries that are being built these days that just do data preparation, data collection, or data labeling for you. And sometimes in some situations, this data collection may be really expensive, and sometimes the data is there in your organization. Just do a pre-processing, or just prepare the data for the next task. So once the data is available, the next task really is to prepare the data for any machine learning algorithm, any data science algorithm. Preparation of the data is sometimes required because the data is available in heterogeneous formats. It may be available in videos, images, audios, or text format. However, the data science algorithms, they actually require all the data in numeric form. Further, the data may have outliers, some missing attributes, and all that kind of stuff. So data preparation is a really powerful module in the pipeline of the data. Once the data is available, you have to clean up, you have to pre-process, you have to standardize the data, maybe you have to expand the features, maybe you have to reduce the features and stuff like so. All that process that comes under the umbrella of data preparation. Once the data is collected, data is prepared, next is you have to select the model. What kind of model you are going to work with. Even if you have identified that your problem falls under regression or classification or clustering or reinforcement learning, even if you have classified one of the learning paradigms, still in each learning paradigm there are a lot of models to select. And this model selection is really tricky. I mean, what kind of model will work better on our data? Maybe a model work on different kind of data very well, but it may not be well suited for your data. And that's precisely because this is the data that actually guides the selection of the model. It is not some heuristical thing. It is not something. For example, if a particular model, say support vector machine is a model in machine learning model that works very well on a lot of data sets, it may not work on your data set very well. And for example, a very kind of low rated model, let me call the low rated in quotes, because there is no low rated model in machine learning due to a theorem called no free lunch theorem. Let me just call low rated model in terms that it does not perform very well on a lot amount of available data sets. But it may be possible that that particular model, that one model, works very well on your data. That is completely possible. So the selection of the model is guided by the data. And there are a lot of model classes that are available. Which one to choose, that is perfectly complete phase in data science pipeline. Next, once the model somehow is selected, the data is available, the model is selected, you now train the model. You actually build the function. You actually have the model class available, you have prepared data available. Now you really want to build the optimization function, actually estimate the parameters that best map your data to your required results, and that is called model training. And a bulk of time of all the data science pipeline, is gone under the model training. The training takes a lot of time. And in most of the cases, the cloud services are basically required for model training. Maybe the rest of the things, maybe you want them to do locally, but once you want to train the model, you may seek help from cloud services because it is really computational. Once the model is trained, the next is how to basically, so once the model is trained, then you basically have to evaluate the model on unseen data. So there are certain ways to do that, sometimes called cross validation, and there are a lot of tools to actually evaluate the performance of the model that you have trained on your data. Now, once you have collected the data, you have prepared the data, you have selected your model, you have trained your model, you have evaluated your model, and let's say you are convinced with the performance of your model, the next phase is basically to deploy your model eventually on the real situation. Now, after deployment, it may be possible that you collect more data. So you have deployed your model in a real situation, and it just happened that you come up with more data and you want to incorporate more data to improve basically the performance of your model. Then once you have more data, you actually go back and you go to the same process again, and basically you retrain your model, sometimes retrain, and sometimes mostly you do incremental learning, or sometimes called the online learning, that you adopt the new samples of the data to improve the existing model, and you may then evaluate the model and you deploy it again, or you may actually supply the new version of the model based on. So more and more data is coming, the model is being adapted, the data and the incremental learning is happening on the way. Also, the incremental learning sometimes happens due to not just the availability of more data, but sometimes the feedback from the deployed place. So you have deployed your data, you have deployed your model somewhere, and you get certain feedbacks that your model is performing this much on these kind of situations and stuff like so. So you may adopt the training accordingly to actually do the incremental training of your model. So that's the workflow of any data science project. So basically, if you, because in your organization you might be interested in a lot of improvements based on a lot of data that you have recorded, based on a lot of experience that you have already logged somewhere. So data science, this is the data science pipeline. If you have data, if you know what kind of predictions or what kind of modeling you really want, then you should really go and just select a particular particular model for you. The training packages are available. There are tools that will help you training the model evaluation methods are there. You maybe before deployment you can improve your business strategies if you have data and if you know what kind of predictions you are going to make from your data. The tools are available, the software are available, the cloud services, the computational software, the data resources, and the data science, all services, they are basically available. Just this is you who have to bring the data. This is you who have to decide what kind of predictions you want to make from the data. Then everything else is roughly available. So yeah, this wraps up this video. Thanks for watching, and see you next time.